first lesson for you for generic parameters. Generic parameters from both the supplier's point of view and the client's point of view. Suppliers will be the side to write the code with generic parameters. The client side will be the side to instantiate the generic parameters. So that's the crucial difference. So the slide we show, that's actually the supplier side because we are trying to define the abstract stack and later on my stack. Right? So here from the supplier's point of view, well, have you really wondered about, so here, so the way we actually do, let's say in your C function, the way you do the function is, you actually define the function and then take addition, I and j being integer, rather than defining one function called add 1 to 2, add 1 minus 3 to 4, etc. The way, so what we're doing is we parameterize the values of the operands into types of integer. So that can really substantially reduce the code and also to make the implementation earlier or definition earlier. The generic parameters idea is very similar, very similar. So try to keep this example in mind, the way we parameterize the values for arguments. Okay, so these are the two use cases for generic parameters. The first case is if this might be a little bit abstract, but I'll try to relate that to the stack example. This first one is the supported features of your class are concerned about how the stored data should be put. Okay? What I meant by this is, if you go back to the stack example, over there, you can see the code there. What we intend to do here is to implement a last in, first out collection, right? What you store in the collection somehow doesn't really matter. If you store a stack of integers, stack of strings, stack of person account, doesn't matter. As long as you're stored in a last in, first out manner, then that's exactly the purpose of the stack. So that's why I said the first trigger for using a generic parameter is if your class are only concerned about how the data items there, in this case, whatever data you store in the stack, you're only concerned about how the data are actually stored, or the shape of the collection, in this case, last in, first out. Okay? And the second trigger for using generic parameter is, so use when the type of individual data items is irrelevant as far as the shape of the collection is. That means, let's say we're defining a stack, and go back to the stack class there. You can see that, for example, here. This is not really implementation, but you can imagine that. Let's say for this put feature, so we are trying to put the item to the end of the stack. We only, well, let me show you some diagram like that. Let's say if this is the existing stack, let's say this is the current top, okay? Now we are trying to add a new element here. So that's what we expect the push or put operation to do, right? But do we actually try to change the individual elements, the contents of them? We don't, right? We only try to change the shape of the stack by adding one element. So that element here becomes the new top of the stack. But we are not intending to change the contents of the item here. So individual elements there are not really important. It's really important how they are organized together, the way they store. Okay? So that's the second trigger. Every time you see these two signs for your class to be implemented, then you should really consider using generic parameters. I give you some examples. So for example, stack and V for Q array should be a linear structure. Also, you have tree structure, hash table, etc. Let's say in the case of hash table, you can even take more than one generic parameters. So in this case, remember in hash table, you have the key and the value, right? So it doesn't really matter what the type for the key or what the type of the value is. As long as somehow the key is hashable, then you're okay. Okay? So now also we are still on the supplier side. So when you are programming a class, let's say you're programming a stack with generic parameter G, the supplier should not need to assume any specific features available to the class G. what I meant by this was, if I again go back to the put feature. So here, let's say the put feature is here. And let's say we have some x of type G, which will be later instantiated in the client side. So here, let's say somehow I'm trying to increment this. You wouldn't expect me to say something like x dot, let's say, feature f. So this would not be allowed by the compiler because this G here is not known yet at the moment on the supplier side, right? Later on, let's say, let me just make it more concrete. Let's say, if I say I want to call, let's say withdraw. So which means I am assuming that I'm actually having a stack of accounts. So this X here should be account objects, I'm assuming. However, the Iceberg compiler will not allow you to do that because this G here may be instantiated with accounts, but it may be not. It might be instantiated with a string objects, and string has no withdrawal feature defined there. So that's why from the supplier side, you should make no assumption about what feature might be available to this G here. That's really what I meant. Okay? The only operation that you can do specific to the type is from the client side, which I will show you. Okay, now here. Okay, let me just go back to my notes again here. Now, okay, that's all about the client side. So now from the client side, I'll try to make my notes a little bit better formatted next time. Okay, so to make it easier later. Okay, so now, so starting from, sorry, I'm lost. Starting from somewhere, okay, so here, 113, from the client side, okay? The clients is they only intend to use a chosen collection for storing and retrieving data in a particular way. For example, I would choose to use a stack because I want the last in first out behavior. I would choose a tree because I might expect to do some in order traversal later, as you actually learned from your data structure class. So depending on which collection I want to use. So what you have to do is to say, let's say this is supplier side for your stack. So now on the client side, so let's say if you declare already have a stack, let's say my stack, okay? Of course you have to follow the code to implement implementation principle we just discussed. So here you might say create. Okay, I should start from the declaration. So let's say you're trying to have some local variable here. So let's say there's an integer stack is. So here you can say, I'll just say stack here. So now here, as soon as I actually put some type here, it is going to instantiate the supplier's code with this particular type. Okay? Let me say that's account. Okay? So now, in my implementation body here, I can do, for example, I can say integer stack. Of course, I need to create that first. Create, okay, whatever create clause we have to write. Integer stack dot, let's say, put. Now, I need to put an account here, right? If I simply just put, let's say, ACC1, a string. In this case, the compiler will be able to tell this is actually illegal because in the declaration part, I commit my stack to store account already. So that's why here, if you're trying to say put, and whatever G that the put has over here has to correspond to whatever G that's instantiated for the class, right? They have to match. If I instantiate this G to be account, then this put here should have account as the arguments. Okay? So this is something that can be checked at the compiler time. Okay? So that's why if I say this, it would be considered as illegal. On the other hand, if I say ACC, and I say that's account, of course, then assuming that you also create that somewhere, ACC somewhere, and then you can say integer, sorry, not integer, account stack actually. Also good? So this will be okay, but this will not be okay, because the type of this corresponds to the instantiated type for the generic parameter. And this one does not match with that. Okay? So now,
Excuse me.
so this is actually about how I actually store into the stack. Yes?
What's the type of put inside the put?
Inside the code.
Yes.
Good question. So if you look at the code here, maybe I should, I think I do have the implementation to that. Yes. So if you look at that, so this is one possible implementation for the stack. So here we still have the G here. So you can see the way we do that. So here we are implementing the stack using a linked list. Linked list itself is also G. It's also parameterized. So we are saying whatever so think about this. So
What's G?
G is some parameter,
Oh.
which can be instantiated later. You don't have to call it G. You can call it A, B, C, up to Z, whatever you like. You can call it maybe whatever name you like, as long as it's valid. Just G is typical name for parameter. Okay, think of this is a black box for my stack. And you have the interface function, like put, you have items, etc. Internally, as a sequence, you're actually implementing using a linked list. Right? So that's your implementation. So that's sort of the conceptual sketch to see how the implementation goes. So that's the internal sequence, which might be changed to any other implementation you like. Okay, so here you can see that we are only working to see how the shape of the stack can be changed for each operation. So here we'd say the implementation that we're using should be, the list should be extended with one element to the end. That's how we implement the last in feature, right? And then we increment the counter for the stack, and then to say now the top should be set to the X. Okay? So this is actually supplier's code. Imagine that as soon as the client actually uses this class and instantiates the G to be account, just imagine you have done the substitution in the following, as the following. So you would say put now is instantiated to be X of type account. Implementation here will be a linked list of account. So that's why you can actually do the extend appropriately. Okay, so now one more line to write, and this is also important, because this is actually about storing the objects into the stack. What about retrieving something from the stack? What can you do with that? So now, this might be too low for someone, for some of you, so I will say here. So now I can say account stack dot item. So this will return the top, right? Now what should be the type of this? Generic or account? We're now in the client side. Should this item be still G or should it be account? Account, right? Because we already commit over here that everything that's stored in the stack should be of type account, right? So now we will be able to say something like item dot deposit. So this is valid, and this is also valid. So this is about storing something into it. So this is about retrieving something out of it. And also, once you retrieve the item out, the compiler can figure out if this feature call is actually valid, simply because you have command here to say, I want to use a stack of account. So every feature that's implemented in the supplier side has substituted G by account. So that's why the compiler can figure out if this is valid or not. Any questions? That's really the most difficult part for generic parameter. That's it. If you get lost, you can just say it now.
Can you say it again?
Which one? Which part?
Item deposit.
Sure. You agree that we commit to the account type for stack?
Yes.
Okay. Over there, we actually will replace every occurrence of G by account. So for example, we'd say, so now we have my stack of account, and that will return some item of type account.
Why we need to make it as account? Why we need to make it as account?
Oh, I'm just giving one example to
Oh,
say that's one possible way of instantiating your stack. From the supplier side, they only have to write this one piece of code, but it might be instantiated into many possibilities in the client's code. I might have stack of accounts, stack of transactions, stack of string, and etc. Each one of them is going to instantiate from the same piece of code with that particular type of data. Yes?
Is G, capital G, a reserved keyword in
No,
the
it's not.
example?
So for example, here you can say G, H, just a convention to be uppercase and just one character. Yeah. You can say that I for if you like, actually. Yeah. Really, the G here is just like a parameter, so it doesn't matter how you call that. But you just have to be consistent. If you call this I for here, you have to call it I for here as well. Yes?
So what you're saying is when the stack is empty, then the first element that gets pushed onto the stack, that's the type that it's going to be. That's the point where you determine the type for the stack.
No, not quite. The point we decide that will be from declaration. So as soon as you declare this stack to be of some concrete type, then in this case, the whatever operations you apply to the stack will be relative to the type here. Yeah, good. This will be another exercise for you to do tomorrow in the lab. What I want you to do tomorrow is to create two versions of the stack. One version is stack of objects without the generic parameter. And the other version is exactly this version I showed here. And to compare how we would use them. Okay? Now just imagine that for the supplier side, let's say we think object in iPhone is called any. It's not called object. Okay, so I'm going to say any for now, A and Y. So now let's say we have a stack of any. So which means we are getting rid of the G. And we get, for example, we're replacing your item with simply just any type, just any object we are storing. We have the similar implementation in Java. Yes.
Is this G as a type?
It's a parameter for type.
Oh, it means like integer, int I, int j, like
no,
this?
Not quite. No. That's a good question. So let's say if you're defining an addition operation, you would say I, j of type integer. Okay? In this case, we call I and j the parameters because we parameterize the values for the arguments. Okay? So now the I and j don't have to be called I and j. It can be called k and n, m and n, or x and y, etc. Right? So similar to this idea here. So now we are, instead of, one thing to note. So here we are parameterizing the argument values. Here we are parameterizing the types for the elements. So it's different. That's the difference. However, the idea is similar. Okay? Cannot be already declared as an attribute of type integer, right? Because you have some name clashes, right? You have some name clashes here. So parameter names should not conflict with your existing namespace. In the case of generic parameter here, the G cannot clash with any of the known classes or the known types from the supplier side. But in the client side, you do have to instantiate that with some known type. So that's why I really emphasize you should really think about from the client's point of view and also from the supplier's point of view. It's really different. Okay? You can talk to me offline, actually, to see if you got any. Yes, Ben?
Just real quick.
So you replace this as any, as opposed to just G, right? So now, what's going to change? I don't have another color, so watch what I'm doing. So now, certainly we won't get this part anymore, simply just stack, because we're going to store a stack of any objects, right? So now here, when we say account stack dot put, so this part here would be valid, because anything can be put into the stack, right? Because this type here, instead of G, it will be any, right? And this part will be valid as well. So now you can see you actually got some stack which stores both string an account. And when you are doing this, so this is where the compiler will actually complain to say, no, actually I'm not sure because you say you're only storing any. And the any can be either account or string. So that's why you cannot do this without an explicit cast. So you have to do some cast like what you did in Java. And so the generic parameter basically has two advantages. From the supplier side, it actually makes the code reusable. You just have to write one version of the stack. From the client side, you actually have the guarantee at the runtime that you don't actually have to do an explicit cast for your data operation like deposit here, as long as you actually commit to some type over here in the declaration. Okay, think about those two versions, and I guarantee you this will be on the midterm. Would that help? Good. Someone will just wake up. So list is actually a library type in iPhone. Okay? So list is also a generic, it's also parameterized by some type. So here we're committing ourselves to store a list of accounts. So similar to a stack of accounts, right? So now if I somehow just to do the list traversal here, so now if I say, now I want to extend the list with transaction here, this would not be okay because transaction is incompatible with account, right? And now in the second line here, if I say list.item, then this would be of type account. So that's why I can say deposit 10 over here. Okay, please do try them out in the lab exercise, or you can try them later tonight if you're really keen. Okay, that's about generic parameters. Let me continue. Okay, so now this slide will be mainly just a definition of information hiding, abstraction, encapsulation. I have to admit, this is like a confusing idea between the three, but it's important for you to understand what's really the essence of them. So I think that the bottom line is, you want to make your software, okay, imagine, remember the diagram I showed just a few slides ago, the iceberg, this part. So basically, to decide, think about, let me use a diagram of the board as well. Okay, so the whole thing, you agree, would be the supplier's count, right? The whole thing, either public or private. This part, above the sea level, is somehow exported or made available to the clients. And this part, below the sea level, is actually hidden for the clients because somehow you might make changes to here later. And this part is called the public interface. Above the sea level is called the public interface of your software. So later on, if you change anything in the secret part, they should not affect any clients who have been using your public services. Okay, that's a key thing. So now, the way we actually hide this, like by, for example, in Java, you might declare things like a private attributes. In iPhone, you have the notion called export. Okay, remember we actually have the tag called feature in iPhone Studio, right? In iPhone syntax feature here, right? If you actually put something like none, so this none is a keyword in iPhone. If you say whatever feature I put under here would be corresponding to the secret part. So that means I'm exporting these features to none of the potential clients. Okay, those parts should be hidden. Okay, so so this kind of mechanism is called encapsulation. You're trying to encapsulate some data above, below the sea level. That's called encapsulation. And to decide what to hide and what to be made in public to public. That process is called information hiding. Okay? And abstraction is really about to what details, to what extent, or how many details you want to increment your class. Let's say let's say, for example, information hiding is really about hiding your design decisions. So what to build under, such that later on, if you change your design decision from one to another, they won't affect your clients. Okay? Abstraction, unless encapsulation is actually how we actually hide those details programmatically in the programming languages you use. Abstraction is similar to information hiding, but it's actually a process to actually decide, I want to make this particular feature available in my class, and I want to make that particular feature hidden in my class, and in some cases, maybe there's some feature I don't want to implement. For example, let's say, currently in the stack class, in the abstract version, we actually have item, so that would be the size, the top, to push, and to pop. So here, the abstraction mechanism, the abstraction process gives us the idea that we should support these features only. We don't support anything else. For example, we don't have any feature called sort, to sort the current stack. That's actually simply irrelevant to the current stack, right? As far as the stack functionality is concerned, we only want these features to be supported. And the process of deciding that is called abstraction. You just want to give enough details and appropriate details to your clients. And the way to hide the implementation details here, we say this linked list here exported to none. So this is making that linked list below the C level. So the process of deciding this is called information hiding. And the mechanism of doing this is called encapsulation. Okay? So we can review the slides, and that's all you have to know. Most important thing is know what information hiding is. Okay? Yes?
Okay, so just to clarify, so in the parts where, so feature none, you would, that parts would be secret, export to await. So in there, you would be implementing the generic type?
You can also use a generic type, yes.
So you can use it?
Yes, positive, you can use it, yeah. Because the generic parameter will be declared at the class level.
So anything public, you would have to implement the action.
Oh, I see what you mean. You might be a little bit confused.
Yeah.
Let me show you. So let's say this implementation here. So you can see this part is private.
Yeah.
This part is public. As soon as you instantiate G with account, like over there, you replace every occurrence of G by account, including the private part and the public part, because those parts belong to the supplier's code.
Okay, so once you commit to a certain type, you have to do it even in the secret parts?
Yeah, the secret part is secret in the sense that the clients cannot get access to it.
But you still have to do it?
Yeah, because you can see, to make the public part work, you need a secret part, right? If you only instantiate the G's over here with account, but this here you leave it unspecified, the whole class is not going to work. Yeah. It's only that we don't want the clients to know that we're implementing the stack using a linked list. Yes?
So what is exactly the difference between encapsulation and export?
And exporting. So the export mechanism there is actually one way to encapsulate the attributes or routines in your features, in your class in Iceberg. So in Java, the encapsulation mechanism might be different. You might use a private keyword or protect it, right, in Java. So encapsulation is more like a programming technique, like how you can hide the details that you decide to hide by the processes of information hiding and the abstraction. Okay? Good? Okay, good. So now we are okay with this. So please read through the definition again and ask questions if you have later on. So here we have one example there where the list might be implemented using array list, linked list, or block list, different implementations. So remember the code to interface, not to implementation principle we mentioned. So when you are declaring type in your client code, you should do list as opposed to array list, linked list, or block list, right? You want to depend on the interface, not the implementation. So that's the principle. Okay, so that's how you use the list. If you follow the videos, then I actually show you exactly how to run a loop. That's basically, I think, maybe one of the very few use cases of the list in this class. Okay, that's how you do it. And as I said before, so list is also parameterized by some G. So G is just a convention in IFO using G. I think in Java, I'm not sure, what was the name for Java? Maybe it's called item or something for the G. I kind of forget. Object? No, object is actually different from generic parameter, so don't get confused. Yeah. I'll look it up and show you next time. Okay. So anyway, so here you can see that that's the list class. So it's similar idea. So you can see that the item here is parameterized by G. So if now in the client code, if I say a list of account, then every occurrence of G, including the public part and the private part, will be substituted by account, right? Okay, so that's exactly what I said. So you can see that, so this is Java, so this is a Java case without the generic parameter. So there are 3 examples here. First part is Java simply a list of objects. So you can see here we have to explicitly cast the objects we get from the collection. But if your cast happens to be wrong, then there will be a runtime error, not compile time error. You know why? And for Java generic list, oh, here we put G here, but I don't think that's a convention for Java, but it doesn't matter. Oh, yes, T, yes, good. So T is also okay in iPhone, good man. Good man. Okay, so here, so this is a generic list in Java here. So now you can see that we can actually give, when you follow this example carefully, you can see that we can actually catch the possible runtime error if you didn't have the generic list. If you have the generic list, that, those errors can be caught at the compile time. That's really the value of generic parameter. So try to follow all the examples and try to see if you can understand the picture. And this is exactly what we said, and also the stack example there, compile time error. Okay, so this is one notation. So this is very specific to the IFO syntax. So let me just mention that briefly. So this is a syntax very specific to IFO. You might find it useful in a project or assignment, I'm not sure. So basically, when you have a list, let's say L, list of integer. So let's say somehow you create a list, and because it's deferred, because list is actually not effective, so you have to say, for example, link list of integer. So L dot main. If you simply leave out this part, the compiler is going to complain because list is actually the deferred clause. It's not effective.
Also deferred is not effective.
Okay. So deferred versus effective is like abstract versus concrete in Java.
Means abstract versus real. Is this?
It mean real classes.
It means abstract means the virtual class, and real is the real class, like this.
So deferred class means if you have any of the features unimplemented in your class, then that's deferred, which means you're deferring the implementation until later. Later, I mean in the descendant classes, classes. And if it is effective, that means they got all the features implemented.
Oh, so effective means the normal class.
The normal class, yeah. That's how we call it. Okay, so now, if you say things like L, let's say 2, what do I really mean by here? I'm saying that I'm referring to the second element in the list, right? So the index of list in IFO start with 1. Okay? So let's say this is the list you have. Let's say 10, 15, 20, 25. Starting with 1. So now, when I say L2, I'm referring to this element here. Okay? So I can say, so I can do some quality test to see L2 is equal to 15. And this should give me true, right? So the syntax you see over there with the assign over there, that one is to say you can write syntax like L2 is assigned to be, let's say, 10. So that's an assignment symbol. So this would, what this would do is to change the value there to be 10. So that's, so you can see the way we index into the list will be the same. But the first line is doing some equality test. And the second one is doing some assignments into the position. And to enable such assignments, you have to use an assign clause over there. Okay? Yeah. Just to give you some idea. So if you, when you really need to use that, you will know how to use it. Okay, just to mention it to you. So, okay, exactly what I said. So we have a list. So that's how you actually walk through the list. And sometimes you might find it useful not to traverse the whole list. You may want to say, if you're searching some particular elements in the list, you can say, once I find it, I can just go out of the loop. Remember I said in the tutorial, the until condition here is the exit condition, which means as soon as this condition is satisfied, then we should exit from the loop. So we're saying either when the cursor of the list reaches the end, which means that we have traversed through all the items, or we actually have found the elements we are intend to find. Either one. Okay, let's say if we happen to find the elements in the second elements, but there are actually 1,000 items in the list, we can just break the loop in the second iteration. That's actually what this Boolean condition is saying. This is actually a very useful pattern for you to use when you write the loops. Okay, you can also
What's the force means? What's the force means?
over there.
The dark greens.
Fourth? Over
Yes.
here.
Yes.
So fourth means to move the cursor one position to the right.
Oh.
So fourth has some precondition. What should that be? If you're trying to move your cursor position one to the right, so what precondition should
The null, the next not be null.
You're getting there, yeah, to say you are now currently in the last position because you have nowhere to go to the right. So this is the cursor. So when you say cursor, so when you say start, sorry, let me say it again. So this is the cursor position where it's saying after. So if you're currently in the last item here, and then you call the fourth there, and then you move here. So this is the after position, which means you can no longer go any further. Okay, yes.
Is after hold, I'm assuming after holds like a Boolean value?
Exactly, as a Boolean. So that's why you can, so or else is like a disjunction. Yes.
Does it matter which way it's written in the after statement? So it's on that.
You mean the or else here?
Yeah.
Very good question. Very good question. In Java, remember the conjunction you put is actually ampersand, ampersand, or, SAP, Q, R, S. We call these operators the short circuits in Java. You know why? We call them short circuits. Just say, okay. Answers. First one. Anyone who says it's not false, it would be more appropriate to put the found X here and after there. How come? Let's say you have 1,000 list, 1,000 items in the list, 1 million items in the list. This would be true only when, so this would be true. Let me see if that will work. Okay, pardon me, actually this will work. Let's say if you have 1 million items here, okay, let's say it's a very long list. The after will be true only if the cursor has moved to here. Okay, until then, the after will simply just be false, right? So you will always try to evaluate this expression here. As soon as, let's say in the middle of the list, you actually found the items you intend to find, then this part will be true, and which will make the whole expression true. Okay, good. This is not really science implementation, but you're gonna learn that anyway. Okay, deferred clause I mentioned, and then, okay, so these are the contracts for the different cursor positions. So similar to the contract for offer, you can just go over that yourself, and you try to see if there's any important thing I would like to mention. This is the most important table of the day, right? About the precondition, postcondition, etc. I would, in a test or an exam, I would test you about this table in some way. I wouldn't ask you to write a table per se, but I'm going to ask you to say, how would you actually interpret such precondition or postcondition, etc. So make sure you really understand this table by heart. It's really important. Okay? So you can see, for the same precondition, it would be the obligation for the client to satisfy. But meanwhile, the same precondition is the benefits of the supplier, right? And symmetrically true for the postcondition. Yes.
So what's the yellow means?
The yellow, just
Yeah.
different color.
Oh. But what's the special meaning? Is this no?
Well, okay. The reason that is to highlight to say these two preconditions are the same preconditions.
Oh.
They can be red if you like. Should I change that to red for you? Okay. Good. Okay, so this is actually one example to instantiate that table to say for the contracts of moving the cursor position one step further. So for example, you can see that for the clients, they have to make sure before they call the fourth, they want to make sure they don't reach that position in the list. They are not at the end of the list. And the post condition is their benefits. So if they satisfy that precondition, they can make sure the cursors is properly moved. And the same for the supplier. You can just read it yourself. Okay, so I think we are getting to the very end of these slides. So now, an object is a machine. So you can see that these are the interfaces. So you have no idea how this recording or DVD player is actually implemented, right? You have no idea. Just know the interface. And then, so this is what's hidden from you. Okay, just to illustrate the idea. Information hiding. Okay, so these will be the last two slides for you to learn. So this is really about terminology. Okay, let me show you both views at the same time. So it looks complicated, but it's not really complicated. It's just a little bit confusing. So on the left side, so this is the terminology from the client's point of view. From the right-hand side is the terminology from the supplier's point of view. Let's have a look at the clients. As far as me as a client is concerned, I only see the feature either as a command or as a query. Okay? It is a command when it actually returns nothing. It is a query when it actually returns something to me. Okay? However, how the query is actually implemented, I don't care. Remember the uniform access principle. When the query actually doesn't take any arguments, like say the balance in the bank. So it doesn't matter how you implement the balance. You might implement that by storage as an attribute, or you might implement that by using a computation, a function. Refer to video 8 for that if you haven't got there. Okay, from the supplier's point of view, of course they care more about the interpretation. So here you can see the feature. So you can see from both sides we start with the notion of feature. So here the supplier only cares about whether he's going to implement this by using computation or memory. So if that's memory, simply just an attribute, store the value directly. If that's computation, just another name called routine. Okay, and then you can either return some result for the routine or not to return a result. Just different terminology. Okay, for you to understand. Okay, so one more thing there's another principle here. You can see we have seen quite a few principles. So far we have covered uniform access principle, okay, code to interface, not to implementation principle. And this is the third one, also information hiding is another one. And here we have command query separation principle. Very easy, actually. So let's say here, let's say if you have account objects here, so withdraw is actually a command because it doesn't return anything back to the client, right? It doesn't, yeah, it simply just change the state of the bank. Now the balance here, if I ask the same questions multiple times between to withdraw or deposit, I should expect the answer to be the same. Why not? I do, right? However, of course, you would expect the balance to be different after the deposit, that's for sure. But just between the state updates, the query should have no side effects. Okay? There's something that fancy name for that, which is called referential transparency. So if you're referring to this particular query here, its value should be transparent. It should be substitutable by whatever the current balance is. Let's say if current balance is actually 10, for example, they can simply substitute this account balance by 10 in these two cases without making any error. Okay, that means the balance should not make any changes to the states. So that's a command separation, command query separation principle. Command should not, command can make changes to the state as expected. However, queries should not make any changes to the state. Unfortunately, this is not checked at the compile time because it is undecidable to actually make sure you have made no changes to your states. Okay, so this can only be forced by your mind, really. So you gotta make sure you follow this principle here. Okay, there's a summary. Would you like to have 5 minutes break and then we continue for 20 minutes? Or, okay, 5 minutes, how about that? And then we'll start a new slides.